So let's say I have x of t equals 2t plus 1. Okay, so that would be my equation for x using time. And then my y equation, maybe let's go 1 minus t squared. And then I always have to give a domain for t. Okay, like in this one, with the squirrel running around. Okay, time started at 0, and time ended at, I don't know, so whenever the time was stopped. So maybe in this case it took the squirrel 5 seconds to do that path. So my t would go from 0 to 5. Okay, well, if I'm going to give you two equations here, I got to give you where does t start, where does t end, so you know where to start and stop the little curve. So usually we start with 0. So let's say for t between 0 and maybe just 4, okay? And I don't have a context for this one, so I mean it would depend. T is time, so maybe time was in seconds, maybe it was in hours or minutes or whatever. To do what we need to do, it doesn't really matter. But if it was actually talking about something real, you'd have to have some kind of value or some kind of unit for that t that you're using. Okay, so we need to figure out what this curve looks like. We want to plot it out. Okay, so we need to come up with what are all the little ordered pairs, and then, like we normally do, plot the different ordered pairs and then connect the dots. Okay, but the trick is this time our input is time. Okay. So you guys have made XY charts before, right, in algebra when you're plotting points and you put it all together. So we're going to make, since we have three things, a TXY chart. It's going to have 3 columns to it. And t runs from 0 to 4, so we'll go up by 1. So 0, 1, 2, 3, and 4. So we'll plot 5 points here. All right, now making the rest of the chart's pretty straightforward. You know what t is for each different row, so you've got 2 equations to plug into, one for x, one for y. So you can use that then to quickly fill out the rest of the chart. So take a minute and do that. Okay, start with x, plug all those numbers into the x equation, fill up that column, then go over to the y equation, do the same thing for that. Okay, I'm going to freeze this, and then I'll quickly put them in, and then I'll unfreeze it, and we can check and see if we got the same thing. Okay, so maybe I'm going a little too fast, but if you're done, you can check it out. That's what I got. All right, and each one of these rows is another ordered pair, right? An x and y that go together. So we've got some points that we can plot then. Go from 1 to 9, y between 1 and negative 15. So we just need to make sure that our coordinate plane that we draw matches that. So y, we're going really negative. X, we're going positive. So we're going to be in the 3rd quadrant here. Or 4th quadrant, sorry. Okay, so let's see what scale we need. For y, we got to get down to negative 15. So maybe, I guess, counting by 4s would work the best for what I've got here. So that would make this positive 4. And then the x, we just got to get up to 9. So I'm going to count by 2's. But however you want to set up your scale, as long as it makes sense that you can see everything, that's fine. So, all right, so let's just start plotting these points. So we got 1, 1, so 1, 1 is about right there. 3, 0, be here. 5, negative 3, about there. 7, negative 8. And 9, negative 15 would be about right there. Okay, and then just connect up the dots. Now be careful though. Don't go beyond the initial and terminal points though. Okay, it doesn't keep going. It starts and it stops. So it's this curve, but just like that. Okay, here's your initial point. Okay, that's when time was equal to 0. And here's your terminal point. That's when time was equal to 4. Okay. Now, having the information that we have now, we've got a graph of a function, which we could have gotten without parametric equations, but we have the additional information now, too, about time. Okay. So, where was this object when time was equal to 1? Well, I can go over to my chart. It was at 3, 0. And I can even label that right on the graph if I want. So kind of in the last point, you can go through and just start kind of entering in that information too. That's where t was equal to 1. Here's when t was equal to 2. Here's when t was equal to 3. Okay? So you've got a very detailed look at the path of this object. Okay? Where it was, when it was, is all on the same graph together. Okay, that's what parametric equations do. Okay, they allow you to see the path of the object and include the time with it as well. Okay, that's the idea with that. So the other thing that we will do with parametric equations is, let's say I want to know what the equation of the curve is, just using x and y. Okay? So yeah, this is great. I've got the time and all that on there. Oh, just what is the equation of this curve? Y equals what? What would that be? So we can do a little bit of algebra to help combine those together. Okay? So when I'm done, I'm going to have an equation using x and y, but what's going to be eliminated then? T. So I want to take these two equations that I have up here, put them together somehow, but eliminate t. How might I do that? How can you combine two equations together by eliminating a variable? Yeah. Nope, we actually don't need the inverses here. That's going to come up later, though. That is related to this, though. Yeah. Yeah, there's going to be a way that we're going to have to make them equal to one another so that we can then, put them equal and then get rid of t. So let's think about that process for a minute. I'm going to come down here, the notation for right now, and just take a look at these two equations. X equals 2t plus 1, and y equals 1 minus t squared. Now, whether we're making them equal to one another, which there is a way to do that, and it's a valid way to do it, but sometimes it creates a little more work, or not, really the crux of the matter is it's going to involve a substitution of some sort. You eliminate variables when you substitute in for one, because as soon as that substitution happens, that new piece comes in, that old variable that was there is now gone, right? So we want to get rid of t, okay? So let's do this. Take the x equation. Solve it for t. It's going to be a couple steps, but I bet you can do it in your head. So what is that? What is t equal to if you solve that first equation? It's going to be what? Still going to have x in it, though. Yeah.
Negative x plus 1 divided by 2.
You're close. X minus 1 divided by 2. You got to subtract the 1 over and then divide by 2. So it would look like that. Okay. So, anybody see the substitution I need to make now? If t is equal to x minus 1 over 2, take a look at the y equation. What does the y equation have in it as its variable? T. So what can I do? Take that t that's in that second equation and make it what? Right, just make it the x minus 1 over 2. Okay, so we're doing a kind of a composition of functions here like we were doing yesterday. But basically it's just a substitution. So t equals that, so replace t with what it's equal to. So y equals 1 minus x minus 1 over 2 squared. Okay, so if we were to graph this, which we are in just a minute, we're going to do it on a calculator. So if we look at this graph, this right here should be a piece of this. Does that make sense? Because this has no restriction on where it starts and stops, right? It's just going to keep going. But this right here has a particular starting point and ending point, but this little piece here should be a part of this entire curve, okay? So take a look. Graph it on your calculator. Make your window the same as this, okay? The same as the graph we produced, okay? Change that window up to make it look the same, and then take a look at that graph. It should go right over where those points are that we just plotted. I will do the same. All right, so 1 minus. And be careful about how you plot these, or how you type it in, because it can be a little bit tricky with the parentheses. So should look like that. It's 1 minus x minus 1 in parentheses over 2, and then that whole thing in parentheses squared. That's what it is. All right, and then make sure your window matches. Our x's went we'll go 0 to 10 maybe, just to make it a little bigger. And our y's, we were all the way down to negative 15, so maybe we'll go negative like 16, and then the max, I don't know, maybe like 2 or something. All right, so let's see if we got the same shape as this guy here. So, same thing, right? So what we've done is we've come up with the equation for the curve that our little object was traveling along, but like I said, it's the entire curve. It's not just that little piece of it that parametric equation is measuring. Okay. So I think that is where I'm going to stop today, actually. I'm going to give you guys a little bit of time to hang out here. The next thing I'm going to jump into is inverses, and I'd rather just do that all on the same day, so we're not breaking it up. So we will stop.